Hi everyone! How are you today? Welcome to my channel. Again, this is Mr. Alistair D. Apale, or alias, or you can call me Emma Watson. So welcome, once again, welcome to my channel. I hope you're doing great and you're doing good as of this moment in the midst of pandemic. Let's not pressure things in here. Let's enjoy and have fun with our learnings in mathematics because as our principal, math is fun. Okay, so do not be afraid of watching this video because the video will not really scare you, but it will help you understand a lot of things in mathematics. We will learn math in a nice way, in a more fun rather, and more simple, but um content based discussion. Okay, so let's have fun and enjoy the show. Okay, so before anything else, I just want to remind everybody, if you like this page or this channel rather, kindly click the button or the like button, and also you can share this video to your friends, especially those who are struggling mathematics. This is the only way that you can help your friends, your classmates to really understand the lessons or topics that we're going to discuss in this session. Is that okay? Okay, I hope you'll do it. Sharing is the best blessing for me. Okay, so another thing also, I want you to subscribe in my channel. Do not forget to subscribe and put some comments if you have some comments, especially if you have learned something or if you want to request a topic that I want to discuss. Is that okay? That is so exciting. So I guess you're all ready with our new topic this session. So last time we discussed about sets. We define what is a set, and we define that set is a group or collection of objects, any objects. So we can relate sets in our real life situation. How? Everything in this world is grouped and classified because God created us by organizing the species, different species. So meaning to say sets are applicable or it is being used already. So let's just be aware of it. Okay, that's the only thing. Another thing also that we discussed last time is was about the elements of a set. So every set has elements or members. Okay, and another discussions that are topics that we had last time was about naming or describing the different methods in sets or in describing the elements of the set. We have the descriptive method, the first one. The second one was listing or rooster method. The third one was set builder notation, where we use variables in describing the sets. And also we stopped with our second video discussions last time in the elements of the set. So we just had to identify rather how or if a certain object or elements is a member or not in a given set. So we stopped in there. So as I promised, for today's session, we are going to discuss about well-defined sets. So now we will start with our new topic this session. So are you excited? I know you're all excited. I am also excited too. So let me share with you our topic this uh, session. It's evening here, so have a good evening, everyone. Have a good evening, everyone, rather. So, what is a well-defined set? How will you define a well-defined set? It's awkward. How will you define a well-defined set? It's so funny. Okay, now, how what comes in your mind when you hear the word well-defined sets? Hmm, it's not ambiguous, or shall I say not clear. Okay. Another thing also is it's clear. Yeah, of course. So is the meaning related to the formal definition of a well-defined set? Let's see. So according to our standard definition about well-defined sets, a set must be well-defined. Why? Let's see. This means, or so we will identify first or describe what is a well-defined set. When we say well-defined sets class, that means that our description in our elements or in the elements of a given set is clear and ambiguous. So um I highlighted the word clear and unambiguous. So meaning to say, once the given or the elements of a given set is clear rather and unambiguous, that means the set is well defined. Okay? So I hope you can follow. Let's have an example. Tall people. A set of tall people. So try to imagine tall people. When you say tall people, is it well defined? Hmm. Next question. Is it clear to say tall people? Can you define them? Can you tell me the tall people? So it's hard. Actually, it's very hard to really get or understand the tall people because there are many tall people. It's uncountable. So meaning to say, tall people is not a well-defined set. Why not well-defined set? It is a set, but it is not well-defined. I will make clear on this. Please just add the word well-defined. So it's not a well-defined set, but it is a set. Why not well-defined set, sir? Because class, people tend to disagree about what tall means. Meaning to say, there are a lot of tall people in the world. Yes. So meaning to say you cannot collect them all. That's why it is not considered as a well-defined set. Let's have another example. Okay. Pretty girls in the Philippines who belongs to this a group of or a set of beautiful people or girls in the Philippines. Are you one of them? Okay, another going back. Another example is pretty girls in the Philippines. So, pretty girls in the Philippines, is it a well-defined or not? Hmm, let's see. It might be difficult, class, to determine if a particular girl belongs to the set, since beauty is subjective. Because when you try to really think of the elements or members of this set, pretty girls in the Philippines, there are a lot. And I'm one of them. I'm just joking. You're one of them. Okay, so there are a lot. You cannot collect them all. It's so subjective. That's why this type or this set or a set of pretty girls in the Philippines is not considered as a well-defined set. In short, it is not well-defined set. So again, pretty girls in the Philippines is not well-defined set. Why again? Because this gives us not clear and ambiguous description of our elements in a given set. So I want you to remember that one. So now, what are those well-defined sets, sir? What are the examples? Okay, the next part are the example, or it shows an example of a well-defined set. So what are these? Example, letters in the English alphabet. Now, I have a question. How many letters, or can you identify or determine the number of letters in an English alphabet? Yes, you know it. In your elementary, way back in your elementary days. Since you know the number of letters in an English alphabet, then you can say that the elements of that given set is clear and not ambiguous. That means letters in the English alphabet is considered as a well-defined set. So it's a well-defined because you can collect them. It's very clear. You know how many are they. Am I correct? Yes, I am. Okay. Now, let's have another example. Teachers in your school. This one. Teachers in your school. How many teachers do you have in your school? Hmm? How many? How many of them can you identify? Example, in your section. Can you? Yes, you can. So meaning to say it's clear. Um it shows that it's clear and unambiguous. That's why teachers in your school is considered as a well-defined set. Another example is the distinct letters in the word honesty. So it's very pretty obvious. The word honesty, distinct letters. How many letters do we have or distinct letters? Meaning to say, when we say distinct, that means it will never be repeated if there is a repeated letters. So, uh, distinct letters in the word honesty. So there are 2, 4, 6, 7 of them. So since you can identify the number of letters in the set in the word honesty, that means this kind of set or this given set, the distinct letters in the word honesty, is a well-defined set. So why? Because we know exactly if an object is an element of the set or not. And that makes it clear and unambiguous. So meaning the sets or these sets that I am mentioning are well-defined sets. What else? Your subject, what else are examples of well-defined sets? I want you to think about your subjects in grade 7. That is an example of well-defined sets. Why? Because you can identify exactly what subject or how many subjects do you have in your curriculum or in grade 7 curriculum, correct? So most of you have 8 subjects. So meaning to say that is an example of a well-defined set. Why? Because the elements of a given set is clear and unambiguous. So please remember it. Okay. So that's how we define a well-defined set. So in short, class, again, before we go to the next topic, when we say well-defined set again, this is a set where the elements of a given set is clear and unambiguous. Okay? So I want you to remember that one. Okay. Yes. So next, let's proceed for another example so that it will be easier for you to understand the concept that you just obtained about well-defined sets. So in this activity or in this example, you're going to state whether the collection is a well-defined set. Let's have number one. Subjects in grade 7, I just mentioned it. Is it a well-defined or not? Let's see. Give me your answer and your reasons. Yes. Why yes? Why is it it's well-defined set? It's very clear there on the screen. It is posted there because it is clear whether a subject is taught in grade 7 or not. That's why number one example is a well-defined set. Let's have another example. Popular actors. So what do you think? Is it a well-defined or not? Okay, I want to hear your answer and reasons. Hmm. Before you give me your answer, I want you to think about this one. Can you identify popular actors? Is it clear? Isn't it ambiguous? Hmm. So you have to consider that one to identify if it's a well-defined or not. So popular actors, it's not well-defined. So who got the same answer or idea? Okay, I hope you have the same idea. So why is it it's not a well-defined set? Because some people may consider an actor popular while others may not. Another reason also, there are a lot of popular actors. You can't really, there are a lot of questions in this given set. Which? Of which? Who? Where? Correct? So it's not really clear. That's why popular actors is considered as not a well-defined set. So I hope you'll be able to master the concept. And let's now proceed to our next topic. That's how we define a well-defined set. Now, this time, we will be talking about the cardinality of a set. So what is the cardinality of a set? I want you to just first observe the rainbow. Who have seen a rainbow in here before? Of course, most of us are familiar with rainbows, especially its colors, 7 colors. So how many colors do we have in a rainbow? I want you to observe the illustration. Another, how many of these colors are the primary colors? I want you to remember rather, I want you to remember the question. How many colors are there in a rainbow? How many of these colors are the primary colors? These questions will be related to our topic, our next topic, which is cardinality of a set. So let's see. We all know that there are 7 colors in the rainbow, in a rainbow rather, correct? We have the red, orange, yellow, green, blue, indigo, violet. So if we represent the colors of a rainbow as I'll just highlight, set A, this one, we denote the number of elements in set A as this symbol. Okay, I am highlighting it. So you can read this one as a number of elements in a set A, or N of A in other mathematical readings. So which is equal to 7. So N of A, or the number of elements in a set A, is equal to 7. That means again, A there represents the what? The colors of the rainbow. Again, set A represents there as uh, colors of the rainbow. And since we are looking for the number of elements, the number of elements refers to the cardinality of a set. So which is N of A is equal to 7. So in short class, when we talk about cardinality of a set, that means it refers to the number of elements in a given set. Again, when we say cardinality of a set, that means a number or the number of elements in a given set. So since we are referring our set as the colors of the rainbow, therefore the cardinality of it is equal to 7. Okay? So I hope you can follow. Okay. Now, as what I've said, when you are referring to how many question, it refers to cardinality of a set. Again, the answer to the question how many is a cardinal number. Okay? So don't forget, the answer to the question how many is a cardinal number. So, if another example, if B represents to the primary colors, then our elements of the set B are listed below. On the screen, posted on the screen rather. We have red, yellow, and blue. Are you still there? Okay, I hope you're still there. Yeah. Set B, if set B represents primary colors, then the elements of set B are red, yellow, and blue. So now, its cardinal number is 3, written in N of B is equal to 3. This one. So meaning to say, since there are 3 elements in this given set B, therefore the cardinal number is now 3, or N of B is equal to 3, as I encircled. And we say that the cardinality of set B rather, is equal to 3. So do not forget that one. Okay? So I hope you are getting something so far in our discussion. Let's make this discussion more fun and productive. So again, before we live in this topic, cardinality of a set, I want you to just put in your mind so that you will not forget a simple definition for the cardinality of a set. When we say cardinality again, that means number of elements or members in a given set. That's it. It can be represented in a symbol n of A or n of B. It depends upon the variable used in our set. Okay, so let's try to practice your learnings for a while. Okay, let's do the example number 6. So in this example, you're going to identify the cardinality of the following sets. So this one, letter A, set V, vowels in the alphabet. Hmm. Okay, so since there are 5 vowels in the alphabet, then the n of V is equal to 5. In short, its cardinality is equal to 5. Who got the same answer? I hope you have the same answer. Let's do another. Yes, let's do the other one. Another example. Set E. Set E consists of numbers 1, 3, 5, 7, 9, 11. Now, I want you to think about this given. What is now the cardinality of this set? Try to give a guess. Okay, let's see if your guess is correct. So n of E is equal to 6. Who got the same answer? I hope you got all the correct answer. Very good. Thumbs up. Okay. So now, so letter C, set S includes the elements of students who ride a submarine to school every day. What do you think? Huh? Okay, let's see if your answer is correct. Try to compare. So, since there are no students who ride a submarine to school every day, imagine riding in a submarine. There's none, of course. That's so impossible. Again, since this question is so funny and so hilarious. So, since there are no students who ride a submarine to school every day, then the cardinality is equal to 0. So, who got the correct answer? Now, question, sir, is it possible that there is no elements in a given set? It's so obvious in letter C. It's possible, yes. It's possible that there is no element in a given set. So, what do you call that? What is now? Or how do you call that set? So again, notice that some sets have no elements. As what I've said, it's not all the time that sets have elements or set rather has elements. There are cases that there are some sets have no elements. For instance, n of s is equal to 0, just like in letter C, example letter C. So now, I want you to take down note, a set with no elements is called a null set. Okay? Again, a set with no elements is called an empty or null set. It is also denoted by the symbol. This one, I want you to remember the symbol for a null set. Again, a null set is a set with no elements. So denoted or represented with the symbol, this one, a pair of braces, or this one. So there are two symbols that will represent a null set. I want you to remember the symbol because it will be helpful for you to understand some symbols or the language of set. Okay, so I guess you now got the concept. I hope so. I am hoping everybody that you have learned something or you learned about the cardinality of set. So now our next topic, our last topic. This is the last for this week. You're excited because you want to relax now? Okay, so um, our last topic for this week is all about finite and infinite sets. Have you heard the word finite and infinite sets before? If not yet, then this topic is meant for you. Okay, now, all the sets we have seen so far have been finite sets, meaning that we can list all their elements. So in short class, when we say finite sets, that means it's countable. What's countable, sir? Maihap. You can count them one by one. So if the given set, or if a given set is countable, therefore we can relate it as, or we call it as part of finite sets, or example of a finite sets. Again, finite sets are countable. So meaning to say they have limit. Okay, they have ending. Na ay ending. Walay forever. That's what we call finite sets. So now, here are two examples. Whole numbers between 2000 and 2005. It sounds like mathematical, right? So the example that I have here for finite sets are mathematical. So whole numbers between 2000 and 2005. What are those? Example, we have 2001, 2002, 2003, and 2004. So topographical error, that's 2004. So in this case, how many are they? There are four. So meaning to say it's countable. Can you count them all? Yes, and you can count their elements. The number of elements, there are four. So meaning to say they are part or example of finite sets since it's countable. Okay, got it? I hope so. Next, whole numbers between 2000 and 3000. So you have example there, 2001, 2002 until 2099. So I lack zero there. So sorry. 2099. So now I want you to try to think about that one. Why is it's infinite? Why is it's finite sets? Because it's countable. So meaning to say, when the elements of a given set are countable, if a set is countable, then it is an example of finite sets. Got it? I hope so. So now, lastly, we will be talking about infinite sets. So again, as what I've said, there are two types of sets, finite and infinite. So if finite is countable, infinite sets are not countable. All that matters in here is that it is well defined. So infinite sets are well defined sets. However, it is not countable. So infinite sets are not countable. So let's have an example of it. Even whole numbers from zero. What I mean is a set of even whole numbers. Challenge. Can you count all even whole numbers starting from zero? Can you? If you can do that one, then I will give you a perfect score in math. I'm just joking. Okay, you can count them. It's impossible. So many, because it's infinite. It has no limit. So that's why it ends in ellipsis. What is ellipsis? Later, I will emphasize that one. So even whole numbers is an example of an infinite set. So next example, whole numbers greater than 2000, 2001, so on and so forth. Can you give me how many numbers are there? Oh, it's so difficult to determine because it's uncountable. So meaning to say, the examples, the last two examples that I gave are what? They are examples of infinite sets, meaning to say they are not countable, but they are well defined. So I want to highlight this one. So another thing also for the infinite sets, it always starts, since it's continuous or infinite, they end with ellipsis. This symbol, you call this one as the two, this one. This symbol shows or determines or represents, it represents ellipsis, okay? Which is used to describe an infinite set. Okay? So again, when we say finite, that's countable. When we say infinite, that's uncountable. Another thing also for infinite, it ends in ellipsis. And that's how it goes here about finite and infinite sets. So very simple, right? So you can now say that math is fun and easy and interesting. I hope so. Okay, so let's try to apply the concept that you just learned about finite and infinite sets. So determine if the given set is finite or infinite. Let's start with this one. The set of counting numbers greater than 20. Finite or infinite? Let's see. It's infinite. Why, sir? It's infinite. So the set is 21, 22, 23, 24, so on and so forth, greater than 20. You can count them all. So you'll just end up rather in ellipsis. Okay, another thing also, the set of whole numbers less than 6. What do you think? It's finite. Who got the correct answer? I hope everybody got the correct answer. So the set is 5, 4, 3, 2, 1, 0 because less than 6. Whole numbers do not include negative numbers. It's not whole. Okay, what I mean, it's numbers, not integers. Okay, so next, the set of whole numbers less than 0. This one, numbers less than 0. Okay, it's finite. It is an empty set, sir. There is, sir, negative numbers. Again, I'm talking about numbers, not integers. Okay? Whole numbers, rather, not integers. So, I hope everybody got the concept. And always remember, class, that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. This channel will help you appreciate and realize the beauty of mathematics. Okay, so I hope you had fun with our discussion for this session. So again, if you like this page or this channel, rather, why I keep on using the word page where in fact it's a channel. Okay, I am enjoying teaching you in my channel, teaching you mathematics about some concepts of mathematics. If you have some concerns, then you can just drop your comments here below in this video. So I really appreciate it. Do not forget to write your name, of course. And of course, and another thing also, if you appreciate it, please, you can share it in Facebook or you can share the link to your friends so that they can also watch. Let's just spread the knowledge. Let's share our blessings, okay? Because we all know that the more you give, the more you will be blessed. So I hope everybody is fine in the midst of pandemic. I know that online class is not that easy. Everybody or all of us are adjusting in this system. So let's just be patient. Let's just be like positive, have a positive outlook or mind because that gives us a successful and productive day. So I hope everybody is fine and doing great. Awesome. Okay, math is fun. Do not forget to subscribe and click like and share. Please share. I hope. Thank you so much. Thank you so much. See you next time around for the week 2 of our Math is Fun Learning channel. Okay, let's Emma Watson is signing off as of this moment. Later on, maybe next, yeah, maybe later I'll have another video. Thank you.